welcome to the second part about immunity. If you haven't watched part one, you need to watch that first for this to make sense. Okay, so we had just finished by saying that the white blood cells clone themselves so they can make lots more antibodies, and you can see all those antibodies going out there into the body, and how the specific T cells, a little bit like the special forces, they come in and they do the final destroying. Okay. And then I mentioned the memory T cells. Now, the memory T cells remember the action so that if you are infected again, your body will remember how to respond. And this time, the reaction will be so much better. Okay, so let's continue to the next part of this process. Now, over here, this poor little sheep has hurt itself, and because that barrier, that skin barrier has been broken, it's been infected by the same virus or the same pathogen. And therefore, it has exactly the same antigens on the pathogen as before. So what happens now? Because this is now not the first time that the body's been invaded by this particular pathogen. So let's have a look at what happens. So this time, your memory cells go, oh, I know how to react. And they then coordinate the B lymphocytes to very, very quickly clone themselves, produce loads and loads of antibodies. In fact, so many more antibodies than the previous time. And also, you can see there in blue, the killer cells are activated very quickly so that they can destroy that pathogen. So it says there, the memory cells which make the antibodies, if the sheep has the same infection again, they bring about a much quicker response. And that is why if you are infected a second time, you won't show symptoms, hopefully, because your body will be able to destroy the pathogen before you even get ill. And this happens with chickenpox. If you get chickenpox as a child, your body builds up, or it acquires an immune response, so that if you later on, maybe when you one day have children and your children get chickenpox, you won't get ill with chickenpox because your body has acquired an immune response to that chickenpox virus and destroys it before you get any spots. And the same thing happens with the vaccination. And in fact, with the COVID vaccination, we get 2 vaccinations because each time the response is better, so that if we are exposed to COVID-19, our body destroys it before we get any of the awful symptoms that are associated with it. So this graph over here is really important for you to copy down. And if you need to go back and make notes, please do. So let's have a look at what this graph is showing us. So on the y-axis, we got the antibody concentration in the blood. And before the vaccine was given, or before the pathogen entered our body, we had very little antibody in the blood for that particular antigen. But the moment you were infected, you can see the level on the graph over here is going up. So the antibody concentration is going up as the B lymphocytes produce antibodies. And then over time, it starts to go down again. Now, the second one might be when you get either a second infection, like you get chickenpox as a parent, or you get exposed to chickenpox as a parent, or like with the COVID vaccination, 21 days later, you get a booster vaccination. And look at what happens the second time round. The second time round, the graph is not only steeper, which means that your antibodies are produced quicker because your memory cells remember how to respond and get your B lymphocytes and your T cells going in action very quickly. But also, the concentration of antibodies is so much higher than the first time. And this is why you don't get to feel any of the symptoms, even though your body has been invaded. It's just destroyed by our amazing immune system so very quickly. So I've seen this graph on a lot of GCSE papers, so make sure that you can describe it. So you're talking about the steepness of the curve, reaching a peak and then slowing down, and comparing the first response to the second response, or the first vaccine with the booster vaccine, and then when you get infected again. So make sure you can describe it. So if I covered it up, can you describe to me what the graph looks like without me seeing it? And then can you use your science that you've learned with your excellent scientific vocabulary to explain why this is happening? So great job. Once this is filled in, that's today's work done. And in the next episode, we're going to have a look at how antibiotics work and how these vaccine and antibiotics are put through clinical trials before they go out to the patients. Great work. Enjoy the rest of your day.